Hello everyone. In the last class we had studied about wireless LAN and the introduction was given to the IEEE 802.11 architecture where basic service set and the extended service set was defined. So here in the extended service set, this uses two types of stations. One is said to be the mobile station and the other is said to be the stationary station. The mobile station is normal inside the basic service set and the stationary stations are nothing but the access points that are part of the wired LAN. When the basic service sets are connected, stations within reach of one another communicate without the access point, and communication between the stations in a basic service set and also outside the basic service set occur via this access point. That is what we had seen in the last class. Let us move on to the next type, which is said to be the station types. There are three types based on the mobility in the wireless LAN. Three station types. One is no transition mobility. Here, station is either stationary or moving inside the one basic service set. That is said to be a no transition mobility. This classification is made based on the mobility in the wireless LAN. Second is BSS transition mobility. That is, here the stations move from one basic service set to another and the movement is within one extended service set. Third is extended service set transition mobility. Here, the stations can move from one extended service set to another extended service set. So these are the three station types. So the first one is no transition mobility, where the stations may stationary or moving inside the basic service set. Second is BSS transition mobility, where the stations move from one basic service set to another and the movement is within one extended service set. And the third is extended service set transition mobility, where the stations can move from one extended service set to another extended service set. Next, let us see about the MAC sublayer. IEEE 802.11 defines two MAC sublayers. So as we have in the data link layer, there are two sublayers. One is logical link control and the other is the media access control, which you can see here. In the data link layer, we have a logical link control sublayer and the media access control sublayer. This media access control sublayer is further subdivided into distributed coordination function and the point coordination function. So the next figure shows the relationship between those DCF PCF, then LLC sublayer and also the physical layer. So here in the MAC sublayer, that is point coordination function and the distributed coordination function. Distributed coordination function is said to be a protocol which provides a contention service. Contention is where the different stations are allowed to contend to access the media, and PCF is said to be a contention-free service where the stations need not contend, they will be given higher priority. That is what we will be seeing in the next explanations. So let us concentrate only in this MAC sublayer, that is media access control sublayer, which is one sublayer in the data link layer. So the first one is about the distributed coordination function. This distributed coordination function, in short, is said to be DCF. It is a protocol defined by IEEE standard at the MAC sublayer. So this distributed coordination function uses CSMA CA as the access method. So already we had seen what is CSMA CA access method. It is in the case of a wireless LAN, since the collision cannot be detected, the collision has to be avoided. So CSMA collision avoidance method is used. It cannot be detected because of the batteries that we use, power supply is limited, the distance between the stations may be more, and there might be a hidden station problem. Because of all these reasons which we have discussed in the last class, wireless LANs prefer CSMA CA, that is, collision has to be avoided because it cannot be detected. So here this uses CSMA CA as the access method. Exchange of data and the control frames in time. Here what happens is, before sending a frame, the source station senses the medium by checking the energy level at the carrier frequency. We can see here. So before sending any frame, the source station senses the medium. It is a persistent method will be used by checking the energy level at the carrier frequency. First, it can use the persistence method with the back off until it finds the channel idle. And after it is idle, it waits for DIFS, that is said to be distributed coordination function interframe space, and then sends a RTS, which is a request to send. So here that is what we had seen it in the last few classes when it was discussed CSMA CA. After RTS, that is destination sends RTS, it waits for SIFS, which is said to be short interframe space, and then sends a CTS, which gives the indication that destination is ready to receive the data, and then the data will be sent from the source to the destination. So during this time, because of this CTS which will reach the other stations are deferred from sending by starting a NAV, which is said to be a network allocation vector. So it is a timer. So in RTS frame, the duration of the time it needs to occupy that particular channel for the data transmission between the source and the destinations will be included. By looking at that duration of the time, the stations that are affected by this transmission, that means the stations, those also needs to contend for the same channel to be accessed to send the data, create a timer called network allocation vector. So when this timer is started, even the duration of time will be there, so that time gets decremented. Once the time ends, that means after so much of time has passed before the stations are allowed to check the channel for idleness. Once that time ends, then the other stations can contend to access the medium. Here there can be a collision during the handshaking. So if no CTS, the sender assumes that there has been a collision. So because of these CTS RTS frame only, collisions can be detected here. And this collision can occur if two stations sends the RTS at the same time, request to send at the same time. Next is about hidden station problem. Even this we have seen. Because of using RTS and CTS, even hidden station problem can be solved. That is, when the CTS is sent from B to A and also to the other nearby stations, it gives the indication that the other stations should refrain from sending. So the hidden station problem will also be solved. That is what is the distributed coordination function. So just remember that this distributed coordination function is a protocol which is defined by the IEEE 802.11 standard at the MAC sublayer, and this uses CSMA CA as the access method, and this provides a contention based service. And here network allocation vector is a timer which will be used here, which provides no carrier sensing. Whenever nav is activated or whenever the station start a nav, for that duration, which is said to be the contention period, during this time carrier sensing will be disabled. Next is the point coordination function. So after the distributed coordination function is the point coordination function, which is PCF, which is used mostly for time sensitive transmission. This is centralized contention-free polling access method. The access point performs polling for stations that are capable of being polled. Here, the point coordination function has more priority than the distributed coordination function. And to give priority, PIFS has been defined. So it is a point coordination function interframe space, which will be shorter than DIFS. So if at the same time a station wants to use only DCF and an access point wants to use PCF, then the access point will be given a priority. That is what the point coordination function is. It is a contention-free service, and usually access points will be given a priority whenever it wants to use PCF. So due to the priority of PCF over DCF, what happens is the stations that use only DCF may not gain access to the medium. Because PCF is given a higher priority, DCF may not get a chance to access the medium. So a repetition interval will be used, which prevents this. So this is designed to cover both the contention-free point coordination function and also contention-based distributed coordination function traffic. So to prevent only PCF gaining the access to access the medium, repetition interval is designed which covers both contention-free point coordination function and contention-based distributed coordination function traffic. So here the repetition interval will be repeated continuously. First, let us see here. The access point wants to use now point coordination function. So it has given a priority, which you can see that. So what it does here, this uses a polling method here. It is said to be a polling method. So access point performs polling for the stations that are capable of being polled. It performs polling. As you have seen, it is a controlled access method. So in the previous modules, we had seen that there are random access methods and the controlled access method to gain access to the media. Aloha, CSMA, all these are said to be the random access methods. And the token passing, select and the poll, reservation, all these are said to be the controlled access methods. So in the poll, there is a primary and the secondary. Primary stations, by using a poll function or a poll frame, ask the secondaries if there is any data to be sent. So if there is no data, it sends a negative acknowledgement. If there is a data, it sends the data. If there is no data, the primary polls the next secondary device. That is what was discussed in the previous class. So even here the same thing happens. The repetition interval will be repeated. It starts with the special control frame called beacon frame, which is given as capital letter B, which is beacon frame. So Here, first the access point. In the repetition interval, first phase is the contention-free phase, which is written as CF. During this contention-free phase, you can see that AP is the access point which performs polling here. So this access point first waits for PIFS. So it is point coordination function interframe space, and then sends us control frame, which is special, which is said to be beacon frame. When stations hear this beacon frame, they start the network allocation vector for the duration of that contention period. You can see that it will be till the CF end. For that duration of the contention period, this nav will be activated of the repetition interval. During this time, no carrier sensing is performed. So once it is over, during this repetition interval, the point controller, which is said to be PC, sends a pole frame, then followed by, that is after a short interframe space, it sends a pole frame. When it sends that pole frame, it will be received by the first secondary station. Those are the poled stations are shown here. So first it will be received by the first secondary station. So after a short interframe space, if that secondary station has a data to be sent, along with the acknowledgement, it sends the data. If there is no data to be sent, it just sends a negative acknowledgement. In that case, the primary device polls the next secondary device. In case if there is a data which is sent, then the access point in return sends acknowledgement or any combination of these, and then the process will be continued. It polls the next. So it is continued till it sends a contention-free end frame. At the end of this contention period, PC sends, that is a point controller sends. During this time, it allows the other stations, which are contention based stations, to use the medium. All these protocols recommend fragmentations, where a large frame will be divided into smaller frames. So that is what we have seen here about the MAC sublayer. Next we'll be discussing about the MAC layer frame. So MAC sublayer has a distributed coordination function and the point coordination function. So distributed coordination function, that is what we had seen. It uses CSMA CA as the access method, and also in the point coordination function, it uses the polling method. Next we'll see the MAC layer frame. This MAC layer frame consists of 9 fields. You can see here. First is the FC field, which is a frame control field, which defines the type of the frame, the subtype of the frame, and also to distributed system. If the transmission is from the distributed or to the distributed system, all those will be specified, which is a 2 byte long, which is 16-bit long. Next is a D bit, which will have a duration of the transmission to set the value of the network allocation vector, which will have a time, duration of transmission time. Next we have 4 address fields, which are 6 bytes each, based on 2 DSN from DS value, which will be discussed next in the addressing mechanism topic. And SC will be the to control the sequence control. It is 2 byte, it is 4 bits are for the fragment number and 12 bit consists the sequence number. Then about the frame body, it will be 0 to 2312 bytes, which contains the information based on type and subtype, which will be seen in the next slide, type and the subtype. And FCS will be a 4 byte, which will have CRC32 error detection sequence. Next is about the types of the frames. So here, as we had seen, the first one, frame control, this field will have a protocol version, type, subtype, 2DS, from DS, more fragmentation, retransmission, power management, more data to be sent, reserved, all that, and wired equivalent, privacy. So first one is the protocol version. The current version used is 0, so always that 2-bit value will be 00. Next is the type field, which is a 2-bit value. If the frame is a management frame, which is used for initial communication between the station and the access point, then the value will be 00. If the frame is a control frame, which is used for accessing the channel and acknowledging the frame, the value will be 01. Or if the frame or the type of the information is a data, it carries data and the control information, the value will be 10. Next is about the subtype. Subtypes we can see it in the next slides, in the next table, about the subtype. These are the subtypes. So 1011, which is of request to send, that is RTS, it is a subtype in the control frame. 1100 for clear to send, 1101 for the acknowledgement. And with respect to the control frame, we have, if the type is 000110, we have already seen. So we have, with respect to the control frames, we have the format will be FC, then D, address 1, address 2, FCS. If the frame sent is a RTS, if the frame sent is CDS or acknowledgement, it will have only FCD, address 1 and FCS. Next is about, all this has to be remembered. Next is more flag. It is set to, when it is set to 1, means more fragments had to be sent. Retry means retransmitted frame. Power management means station is in the power management mode. More data means station has more data to send. So this is about the frame format. So now in the addressing mechanism, which will be discussed next, we'll see about what is 2DS, what is from DS, and what are address 1, address 2, address 3, address 4. This will be discussed in detail. So let us move on to the addressing mechanism. IEEE 802.11 addressing mechanism specifies 4 cases defined by the value of 2 flags in the FC field, that is 2DS and from DS. Each flag can be either 0 or 1, resulting in 4 different situations. The interpretation of the 4 addresses in the MAC depends on the value of these flags. So it depends on 2DS and the from DS field of FC field. So this is the table which should be remembered. It can have 2DS and from DS, which are single bit values. When the value of 2DS and the from DS is 00, so address 1 will have the destination address, address 2 will be the source address, address 3 will be the BSS ID, address 4 will not be applicable. Let us see that. So first is the case 1. So which tells that whenever 2DS and the from DS are 00, that means the transmission of the frame is within a basic service set. It is not in between the distributed system. D stands for distributed system. So within a basic service set between the stations A and B. So the first field, as we have seen here, first address 1 will be the destination, address 2 will be the source, address 3 will be the BSS ID. So here address 1 is destination, that is station B, address 2 is the source station, that is A, and this is BSS ID. Next see the case 2. Case 2 is to DS is 0, from DS is 1. Then the address 1 will be the destination, address 2 will be sending access point, and address 3 will be the source address in that BSS. Here we can see that case 2, when the to DS is 0, from DS is 1, which means that here the transmission is from a distributed system. That means through a distributed system, it is from one BSS to the other BSS. In the case 1, it was within the BSS. Here it is from one BSS to the other BSS through the access point. So the first field will be the destination, that is station B. Second field will be the source, that is the access point, and the third will be the station in source station in that other basic service set, which is station A. So this is what the case 2 is. Next is about the case 3, that is to DS is 1, from DS is 0. So address 1 is receiving AP, address 2 is source, address 3 is the destination. So you can see here case 3, that is address 1 is the access point, which is the destination, because it is from 2 DS is 1, from is 0. It is from one basic service set through the access point, it is moved to the next basic service set. So the source is A, and the address 3 is the station of the other basic service set, which is B. And the last case is case 4, where 2 DS is 1, from DS is 1, where address 1 is receiving AP and the address 2 is sending AP and the address 3 is destination. So it is the case 4 where both are, it is a wireless distribution system. In the case of a wireless distribution system, that is from one BSS to the other BSS through the access point. So the address 1 is the access point 2, address 2 is the access point 1, address 3 is the station of the access point 2, and the address 4 specifically for the wireless distribution system, which is the address of the access point 1, that is of the first basic service set of the source station. So this is about the addressing mechanism. Then we can see about this exposed station problem. What it tells us, sometimes what happens is station C can send the data to D because that area will be free, but C erroneously refrains from sending because of the received RTS. So here actually if C sends a data to D, there will not be a collision, but still it will not be sending the data because of the received RTS, and it is said to be an exposed station problem. So in the next class, we'll be discussing about the physical layer and also the Bluetooth topics. So what is that we have seen as here, the addressing mechanism. So you have to remember with respect to 2DS and the from DS of the frame format, that is which is shown here, that is in the FC we have a 2DS and the from DS. With respect to these values 00, 01, 10, 11, the addressing mechanism is explained, and type and the subtype fields which also you have seen, which should be remembered, and the address 1, address 2, address 3, address 4 depends on these 2DS and the from DS values. So whenever 2DS from DS are 00, you will have the address 1, address 2, address 3 used, where it tells that the data transmission is within the basic service set. So address 1, which will be the destination address, address 2 will be the source address of the stations, and address 3 will be carrying the ID of the basic service set. When it is 01, it is from a distributed system. The data comes from a distributed system, as a result of which we have the address 1 is the destination, address 2 is the sending access point, and address 3 is the source address of that sending access point that you can see here. So which is nothing but address A. of the other basic service set. Next is about case 3, where the value of 2DS is 1 from DS is 0, as a result of which the data is sent from a station A to station B, where the destination is to the access point. So it is the address 1 is access point, address 2 is A, station A, address 3 is station B, and the case 4 where both are 1 1, it is a wireless transmission, that is wireless distribution system. So also about the export station problem, actually C can transmit a data to D, but it erroneously refrains from sending because of the received RTS. It is said to be the export station problem. So we'll continue in the next class with the physical layer and the Bluetooth. Thank you.